everyone! In this video, I'll tell you about ants that were once considered biological mistakes, so-called monster ants, and how evolution didn't eliminate them, but turned them into essential members of the colony. Let's check it out. As you probably know, in every ant colony, roles are clearly defined: workers, soldiers, and queens. Each caste has its own body shape, behavior, and function. But sometimes nature produces ants that do not belong to any of these categories. Scientists call them monster ants. These ants are born with bodies that combine traits from different castes. From birth, their bodies resemble a mosaic, like a biological Frankenstein with body parts combined in unusual ways. For example, a queen-like abdomen, a worker-like thorax, and a soldier-sized head, all in one individual. In our example, the monster is not a queen that lost her wings after mating, nor a gamergate, a worker that can reproduce. No, monster ants are truly different. For decades, biologists believed these ants were nothing more than developmental errors, comparable to a construction blueprint assembled incorrectly. They were assumed to be useless or even harmful to the colony. A study published in the American Naturalist reveals a very different story. Some monster ants are not mistakes at all. They're functional and sometimes essential. Because they combine traits from multiple castes, monster ants can be especially well suited to certain tasks. Some become highly specialized soldiers, optimized for defense or food storage. Others, like in our previous example, develop into wingless queens, capable of founding new colonies without flight, avoiding one of the most dangerous moments in an ant's life. They mate with their brothers inside of the mother nest. Doesn't it remind you of something? So, how are these ants created? Usually, in ant colonies, only queens lay eggs. During larval development, an ant's fate is shaped by delicate interaction between genes, hormones, nutrition, and environmental conditions. In other words, food, care, genes, and even the surrounding environment determine whether a larva becomes a worker, a soldier, or a queen. Occasionally, the system produces an unusual result. If the developmental conditions overlap or conflict, the larva does not fully commit to a single caste. Instead, it develops into a hybrid form expressing traits from several castes at once. These ants are monsters by birth, not by accident later in life. Most of the time, these individuals are extremely rare within a colony. When a so-called monster ant appears, the consequences for the colony can differ. In some cases, the colony benefits. The unusual combination of traits allow the ant to perform hybrid tasks or even entirely new functions. For instance, an ant with an exceptionally large head might initially seem like an anomaly, but the colony can later exploit this trait by using the ant to block or defend nest entrances, like in the genus Cephalotes. In other cases, the mutation provides no clear advantage. If the monster ant does not offer a new or useful function, it is simply integrated into the workforce and carries out standard tasks like any other worker. And colonies that are genetically more likely to produce helpful monster ants gain an advantage. Over generations, natural selection increases the frequency of these once rare forms. What began as a developmental anomaly can become a stable caste integrated into the colony's social structure. We've talked about door-head ants like Cephalotes, but there are many other examples. Honeypot ants, such as Myrmecocystus mexicanus, use some workers as living food stores. Leafcutter ants like Ata can have up to 20 different castes, each with a specific role. And then there are exploding ants like Colobopsis explodens. All of those specialized castes may have started as rare monster individuals that turn out to be useful for the colony. As you can imagine, this discovery has important consequences for the evolutionary theory. Since Darwin, evolution has been understood primarily as a process acting on individuals. In classical Darwinism and later in neo-Darwinism, mutations are favored if they improve an individual's survival or reproduction. But ant colonies challenge this idea. Ants live in highly cooperative societies where individuals are fed, protected, and rarely reproduce on their own. Here, survival does not depend on being faster or stronger than others. Instead, selection acts at the level of the group. Monster ants are not successful because they benefit themselves, but because they increase the survival and efficiency of the colony as a whole. This research adds an important piece to evolutionary theory. It shows that in social organisms, natural selection can shape developmental accidents into functional biological roles. If you enjoyed this look at monster ants and the surprising ways evolution works in ant societies, give this video a like, subscribe to the channel and hit the bell so you don't miss our next deep dive into ant evolution. And if you want to explore this topic further, be sure to check out our full film on ant evolution. See you next time, guys!